take a new file, change to inch pound second, start from the top plane. This origin represents the center of gravity of the vehicle. We'll take infinite length construction lines, vertical lines, center of the vehicle, smart dimension. This will be 25.5 inches, half of the track width of the vehicle. This means the total track width of the vehicle is 51 inches. Okay, just move it upstairs, side. Take horizontal construction lines, infinite length. Smart dimension. Mark this as 54 inches. This is the wheelbase. 54 inches. This is the wheelbase. From the center of gravity to the rear wheels, it is 18.9 inches. It's in the ratio of 35% to 65%. We will be assuming the center of gravity to be at the ratio of 35% from the back. Okay, these four corners represent tires. Start making the tires. The tire profile is 23 by 7 inches, 23 inches. Seven. Take the distance of the kingpin from the center of the tire, which will be 4.1 inches. Make a circle representing the locus of the steering arm. The steering arm length is 3. That is the radius of the circle. The steering arm will be attached to this point and it will move on the locus of this circle. We'll take its radius as 3 inches and the length of the steering arm is 3 inches. Okay. Mark a center line representing the vertical from here. Take a line from this point to the circle. This represents the steering arm. The inclination of the steering arm from the vertical is 44.2 degrees. This is called the steering arm angle from the vertical. Okay. Take a midpoint line. We'll make the rack, which will be situated at the center of the vehicle. Its length is 14.2 inches and it is 5 inches in front from the center of the tires, line joining from the center of the tires. Okay. Select line, connect the steering arm to the rack. This line here represents our tie rod. Copy this value. We'll be needing this value in future. Okay. Take the selection tool, select all these entities, mirror entities, mirror about this vertical center line. Okay, and we have both the left and the right tires. This is the left tire and this is the right tire. We'll be assuming that the vehicle is taking a right turn, and for that we'll assume the turning angle of the outside wheel, the wheel which would be outside when taking a turn. Okay, the vehicle takes a turn from this point for infinite length. Okay, assume the angle, this outer angle, 31.5 degrees. You have to make certain iterations to get the geometry perfectly right. Okay, when you put up the formula for the Ackermann. The 100% Ackermann will give the angle, the inner turning angle, to be 49.99 degrees. Just see, this is a single point where these lines intersect. This shows 100% Ackermann. Okay, assuming this angle and we get the outer angle as 49.99 degrees, the vehicle would take a perfect turn with 100% Ackermann. Okay, measure the turning radius. We'll measure the turning radius from the center of gravity of the vehicle, this to this point. Okay, we'll mark a point here, smart dimension. From this point to this point is our turning radius. This is 69.36 inches. Convert this to meters. Okay, so this sketch represents a vehicle is standing in the position where all the tires, both the tires are facing front, and the vehicle is assumed to turn at an angle, at these angles. Okay, now we'll exit the sketch and we'll take another sketch, and in this sketch we will assume that our vehicle is taking an actual turn. When the vehicle is taking an actual turn, this point, this locus will move to this side, and this locus will move to this side, that pushing the rack. This rack will be pushing the tie rod here, and this point will come somewhere here. The whole arrangement will move. Okay, the whole arrangement will move in the locus. Okay, we'll take a point here, we'll mark the steering radius, take the angle as 31.5 degrees. The inner turning and outer turning angle is 31.5 degrees. 31.5 degrees. From this point, make a circle whose radius will be equal to the tie rod length, the length of the tie rod which we got from here. Okay, this tie rod length. Mark a point at intersection. Okay, this point and this point, the distance between them indicates the rack travel. The rack travel is 1.55 inches. Okay, we'll make the rack, when turning the rack will shift to the right 14.2. Again take a circle, make the locus of the tie rod. The length of the tie rod is this 16.637. Okay, mark a point where this locus of the tie rod and this locus of the steering arm intersect. Okay, mark this point. So this point will be indicating where the steering arm will end after the vehicle takes a right turn. Make the steering arm, connect the steering arm to the rack. This gives the tie rod. Measure this angle here. This is 54.56 degrees. Okay, this is the actual turning angle when the vehicle is taking a right turn. Okay, the geometry here is completed. Let's see where this line intersects. A line where we assume the vehicle is taking a 100% Ackermann turn. From this point, make a line, take its inclination to be as 54.56 degrees, same as this one. Or better, copy this value and paste it here for actual calculations. Take a point. This is the point. This is the actual point where the vehicle would rotate about to take a turn, and measuring this value and this value, the distance between them would give the actual turning radius of the vehicle. Okay, hereby the geometry is completed. Put the values in the calculations. The Ackermann percentage would come here about 97%. Okay, we have completed the geometry.